It is a melody crafted from discarded fragments, a sound born from the silent depths of the ocean. One of Coldplay's albums is not just music, it is a statement forged from literal trash. The record, titled Moon Music, stands as the world's first to be pressed from plastic pieces gathered from rivers and seas. This material was painstakingly recovered from the waters off the coast of Guatemala, beginning a remarkable journey of transformation. From these offshore cleanup missions to coastal recycling plants, a new cycle of rebirth is underway. Here, the collected waste is meticulously cleaned, sorted, and prepared for its conversion back into useful materials, giving what was lost a second life. Each year, a staggering tide of more than 20 million tons of waste floods the world's oceans. Nearly 80% of this deluge is plastic, a substance so resilient it can endure for centuries beneath the waves. These fragments coalesce into massive garbage islands and dangerously infiltrate the food chain, impacting over 700 marine species and eventually humanity itself. Yet environmental organizations see that if properly collected and recycled, much of this ocean waste could be reborn as a valuable raw material. It holds the potential to become everything from recycled plastics and synthetic fibers for the textile industry to reclaimed metals for manufacturing. This process not only saves thousands of kilowatt hours of electricity, but also reduces millions of tons of CO2 emissions. It paves the way for a circular ocean economy, a future where everything once discarded can return to serve a new purpose. Before it can be reborn, it must first be reclaimed. The long journey of ocean waste starts with its collection from the sea, a task that demands highly specialized technology to conquer the harsh, open environment. In vast accumulation zones, like the North Pacific Gyre or the Gulf of Thailand, dedicated cleanup vessels form the front line. From each side of a ship, two hydraulic mechanical arms extend, sweeping the surface in a wide fan-shaped motion to capture a tide of floating debris, from plastic bottles and nylon bags to derelict fishing nets. This captured material is then guided into floating conveyor channels that lead back to the vessel. Once aboard, it moves along stainless steel belts on the deck, where it is funneled down into enormous storage compartments below. A single mission can stretch from 8 to 10 hours, yielding a haul of up to 5 to 10 tons of mixed marine waste. But not all of this debris makes it to the open ocean. A significant portion becomes ensnared in rivers, reservoirs, and canals, forming dense mats that choke the flow of water. In these confined waterways, compact mechanical equipment is brought to bear, most often clamshell excavators mounted on dump trucks. Each steel clamshell, weighing nearly 1,000 pounds, plunges deep into the water, scooping up a mixture of waste: bottles, plastic bags, branches, and even old tires. With every lift, the excavator can haul between 500 and 1,000 pounds of refuse from the depths. This mechanical power allows a single team to clear a river section hundreds of feet long in just a few hours, a rate roughly 10 times faster than what could be achieved by hand. Yet in many coastal regions, the effort remains deeply human. Local fishermen and volunteers venture out in small boats under the blazing sun, armed with simple nets and hooks. An individual might recover only a few hundred pounds of waste in a day, but their tireless work represents the indispensable first step in this vast recycling chain. With the collection phase complete, the gathered waste is ferried to port aboard trash skimmer boats, vessels designed specifically for this purpose. A small skimmer, measuring about 25 to 30 feet in length, can collect around 5 tons of debris during a single 8-hour shift. Once its hold is full, a hydraulic conveyor at the bow rises, unloading the entire payload into a designated receiving area on shore. It is here that the crucial process of initial sorting can finally begin. The freshly deposited mixture is a chaotic assortment of materials: plastic, metal, wood, seaweed, and organic sludge. Workers must first perform a rapid inspection, pulling out any large or hazardous objects like heavy steel nets, oil buoys, and discarded tires. The remaining mass of waste is then scooped onto a feed conveyor, beginning its journey into the screening section. Inside, a massive rotating drum called a trommel screen begins to separate the material by size. Sand, mud, shells, and other small debris fall away through its mesh, leaving the larger bottles and packaging to continue on. This remaining fraction, now composed mostly of plastic and nylon, is sent down a manual sorting belt where a line of workers meticulously separates each material group, preparing it for the next stage of its transformation. While metal, glass, and wood are diverted to their own fates, the most persistent material on Earth is about to begin its rebirth. This is the story of plastic, the durable and troublesome substance that, once adrift in the ocean, is now reclaimed to fuel a more sustainable world. The sorted plastic, nylon, and metal cans arrive at the washing station, caked in the residue of the sea. Long immersion in salt water has left them coated in algae, oil, and microscopic life, a contamination that must be purged before recycling can begin. The waste tumbles into a mechanical washing tank where rotating shafts armed with paddles churn the water, creating a vortex that scours away surface residues and flushes out contaminants. A solution of mild detergents and salt neutralizers works to dissolve chlorides in oil. In some facilities, the water is heated to between 160 and 180 degrees Fahrenheit, enhancing the sterilization process. Depending on the level of contamination, this bath lasts between 15 and 30 minutes. Afterward, the clean materials move into a drum washer, where high-pressure water jets bombard them, stripping away any stubborn sand or algae. From there, a float sink tank leverages density to separate different plastics. PET sinks, while HDPE and PP float, ensuring precise classification. The final steps in this cleansing stage involve a centrifugal dryer to spin off residual moisture, followed by a hot air bath at approximately 170 degrees Fahrenheit. Some larger plants even use ozone deodorizing systems to treat steam emissions, eliminating organic odors and bacteria. With the waste now clean and dry, the next stage of refinement begins: pre-sorting. Of the 7 common types of plastic used globally, PET and HDPE are the most efficiently recycled, so the entire system is engineered to isolate them. A stream of mixed plastics enters a vast rotating steel drum. As it turns, small perforations in its walls allow dust, sand, and tiny fragments to tumble out, a coarse separation that prevents larger bottles from clogging the machinery downstream. The larger items continue onto a manual sorting conveyor. Here, human eyes and hands swiftly remove unwanted materials like metal cans, nylon, and cardboard. Simultaneously, an automated system uses a vortex of air to tear away caps and labels, while magnetic sensors scan the line, ejecting any stray metal fragments. What remains is a uniform stream of clean PET bottles, ready for the violence of the granulator. Now purified, the plastic bottle bodies are fed into the jaws of a high-speed granulator. Inside, hundreds of alloy blades spin at thousands of revolutions per minute, violently shredding the bottles into small, uniform fragments known as flakes. In a single hour, one machine can tear through 2,000 to 3,000 pounds of plastic, transforming a mountain of bottles into a steady stream of material. The resulting flakes, just a few inches across, are now small enough to flow through the subsequent thermal systems without causing blockages. This process does more than just reduce volume. It dramatically improves energy efficiency. The shredded material melts faster in the extrusion machine, saving up to 40% of the electricity needed to melt solid plastic, and ensures the material is uniform before the next phase of precision sorting. The sorting process now shifts from the mechanical to the microscopic. High-speed optical cameras take over, their sensors scanning every individual flake. In just a few thousandths of a second, they analyze color, transparency, and surface texture. A single machine can process over 1,000 fragments per second, achieving an accuracy rate above 95%. The moment the system detects a specific type, a clear PET flake, a green one, a piece of white HDPE or a foreign particle, a precisely aimed jet of compressed air fires, knocking it from the main flow. Each pulse of air acts on a single fragment, weighing less than 1,000th of an ounce, leaving its neighbors undisturbed. The result is a stream of pure, homogeneous plastic flakes, perfectly sorted and ready for pelletizing. The purely sorted flakes are now ready for their final transformation. They are fed into a massive extrusion machine, where they are subjected to a temperature of about 520 degrees Fahrenheit. The plastic melts into a viscous stream, traveling along a giant rotating screw shaft. The immense pressure forces the molten material through an ultrafine metal filter, trapping any last impurities. This molten plastic is then forced through an underwater pelletizer. As it emerges, it is instantly sheared into millions of tiny uniform particles called pellets. A closed-loop water system cools and solidifies them immediately, creating an industrial-grade raw material with a consistent size and a smooth finish. These pellets are now ready to become packaging, synthetic fibers, or even brand new bottles. The cycle nears completion as the recycled PET pellets begin their journey to become new bottles. After a final quality inspection, the material is fed into an injection molding machine and heated to around 480 degrees Fahrenheit. The softened plastic is injected into a steel mold, creating a thick-walled tube with a threaded neck already formed for a cap. These are the preforms, the embryonic stage of a bottle, engineered to withstand the heat and pressure of the processes yet to come. The preforms are then reheated until soft and pliable, and fed into a stretch blow molding machine. With a sudden blast, high-pressure compressed air is injected through the neck, inflating the plastic and pressing it firmly against the inner walls of a bottle-shaped metal mold. In an instant, a preform measuring just 4 to 5 inches tall expands to nearly 4 or 5 times its original size. Automated production lines can churn out thousands of these bottles every few seconds, all while laser sensors monitor wall thickness, clarity, and form to ensure near-perfect consistency. The system can even customize the bottle's capacity, curves, and label placement to match a brand's specific design. After this stage, a fully formed PET bottle is complete, poised for the final steps of cooling and packaging. Fresh from the mold, the bottle is still hot and easily deformed. It is immediately whisked through a rapid cooling chamber where jets of cold air or circulating water stabilize its structure in a matter of seconds. This process is precisely calculated to balance production speed with the bottle's optimal clarity and rigidity. In some modern factories, heat recovered from the bottles is even used to preheat the cooling water, saving significant energy. But before it can leave the factory, every single bottle faces a final, rigorous inspection. A gauntlet of optical sensors, cameras, and pressure systems searches for the slightest flaw, from microscopic cracks and air bubbles to minute deviations in shape. Samples are pulled for mechanical tests to ensure they can withstand tension, compression, and impact, while bottles intended for food undergo chemical analysis to verify no toxic residues remain. Only those that meet every criterion are approved. They are then grouped and stacked onto pallets by automated robots, which organize thousands of units with inch-perfect precision. From the central warehouse, they are shipped out to bottling plants and retailers, completing the journey from ocean waste to a vital resource. Each new bottle is more than just a container. It is a testament to a circular system, where what was once discarded is born anew. From the silent depths, a new resource emerges. It is born not of the earth, but from the scars we left upon the sea. From these lifeless fragments, humanity has engineered a new life cycle. Waste is recovered, cleaned, and reborn, returning to the world as something useful once more. Every bottle, every strand of fiber, every plastic item we hold could now carry a secret history, a past spent drifting on the currents of the ocean. This is more than a story of technology. It is a testament to our ability to turn what was once discarded into a symbol of responsibility and creativity. The ocean still waits to regain its pristine blue, and that long journey back begins not in a factory, but in the awareness of each of us.